In this AP Calculus example, what we're being given is this equation here, y to the third plus y squared equals x squared. And then they want us to find dy dx. They want us to find the derivative of this equation. Well, whenever you look at a problem and you see that you sort of have x's and y's kind of commingling, you've got y's up in this just not a straight y equals example, you know that you're looking at what's known as implicit differentiation. So to do implicit differentiation, what you always want to do is you're going to take this equation you're trying to find the derivative of, and you're going to ddx this equation. Really, whatever they're talking about here as far as dy dx, whatever that might be, that's going to tell you what to dd whatever to the equation you're looking at. So what you do now is you come through and you'll take the derivative of everybody. And when I'm doing implicit differentiation, I've got a little mantra I use, which is every time I take a derivative, I get extra stuff. And what that extra stuff is going to look like is sort of, if you think about this ddx that you're doing to everybody, I envision there being this little box up on top there. And so every time you take the derivative, you'll take the derivative like a normal derivative, and then you'll get a d, and you'll fill that box in with whatever the letter is you just took the derivative of over dx. Also keep in mind as you're doing this that chain rule, product rule, quotient rules, all those rules still apply. So if you run into those, you got to follow those rules as well. Working our way through this right now, starting at the front here, the derivative of y cubed would have been 3y squared. I took the derivative, I get extra stuff. I took the derivative of a y, so I get a dy dx. Done with that piece, on to the next. The derivative of y squared would be 2y. Took the derivative of a y, so again, I get a dy dx. I get my equals, and then I take the derivative of x squared. The derivative of x squared would have been 2x. Took the derivative of an x, so I get a dx dx. The next thing I do after I take my derivatives is I go ahead and do what I call a cleanup step. This problem, this example here doesn't have a lot of cleanup for us, but sometimes you would want to, as you go through, you're just kind of putting the pieces into place based upon your derivative. And as you come back, you kind of want to make sure that everybody's sort of in a number alphabetical order setup, and then with your dy dx's. Also notice that when you get a dx over dx, that's kind of like having a 5 divided by a 5. Those cancel out. That's really the same as a 1. So if I clean this thing up now, I'm looking at 3y squared dy dx plus 2y dy dx equals 2x. What we're trying to do here, keep in mind, is we're trying to find dy dx. We're trying to get a dy dx equals some equation. And so once you've done the cleanup step, now the mission is to solve for dy dx. Treat dy dx like any other variable and get it alone. When you've got multiple dy dx's going on in one of these problems, the key to this, to solving it, is to get everybody that has a dy dx, everything that has a dy dx in it on one side of the equals, and everything that doesn't would go on the other side. This example here is kind of set up for us already. Everybody on the left side has a dy dx in it, and everything on the right side of the equals doesn't. So we're in that mode that we wanted to be in. If you weren't, you got to move things from left to right around the equals to get into this setup. The reason you want this is now that everybody on this left side has a dy dx in it, I can factor a dy dx out of everybody. I can pull that dy dx to the front. That's going to leave me with 3y squared plus 2y, and that's all still equal to 2x. The reason that that's important to us is now we're down to a single dy dx that we can solve for, and these things are being multiplied. So to get dy dx by itself, I'm just going to divide both sides by 3y squared plus 2y. And so out of there, we'll get dy dx equals, those would cancel out, 2x over 3y squared plus 2y. And that would end up being what our dy dx equals. So that's going to be our final answer. And we can see that that would be option C. So implicit differentiation, my mantra is always, every time I take a derivative, I get extra stuff. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.